Hey everyone, it's Mr. Canfield. Today we're doing integrals of transcendental functions. So a couple of points of review. First one is that if we have y is equal to the natural log of x, then y prime is equal to 1 over x. And remember that chain rule still applies here. So if we had y is equal to natural log of x squared minus cosine x, because we're in calculus, the derivative would be 1 over that. And so since it's 1 over that, that's great. But then we would multiply by the derivative of the inside. And you could put it over here to the side, but usually what happens is we'll just put it on top. And instead of putting it in parentheses like that, like instead of saying 1 times the parentheses, we're just going to eliminate all that and just put the derivative on top, which would be 2x. And then negative cosines plus sine. So usually when you take the derivative of natural logs, that's kind of the way that you'll see it in the end. So now that that is back in your brains, let's talk about the antiderivative. So if y is equal to 1 over x, well then, if we were to integrate both sides over here, we can get, oh wait, sorry, I'm thinking differential equation mode. Let's just talk about this on its own. Let's talk about the integral of 1 over x. So integral of 1 over x would just be the, I should use cursive so that doesn't look like 1n. ln x, here's the problem. 1 over x is defined everywhere. ln is not defined everywhere. So we've now introduced domain restriction. The thing is, that's not okay. And if you remember what the 1 over x looks like this, and it's got a vertical asymptote here. These two are vertical reflections of each other, and because of that, over here the derivative anywhere is ln x, and over here, if it was just positive, then it would be ln x. And so what we actually can do is we can say it's ln the absolute value of x. We need the constant of integration as well. This may be a very short video. So that's the big key. And I know that's in our book, but I just wanted to talk about it a little bit more than our book does. So let's see. Our first example says 4 over x dx. So I'm just going to remind you, there's a constant. This is really 4 times 1 over x, right? So I could rewrite this as 4 integral of 1 over x dx. So I could say that the integral then is 4 ln absolute value of x plus c. Similarly, in number 2, sorry for the earthquakes. In number 2, we've got 4 over 3 minus 6x dx. So I could pull the 4 out. And so 3 minus 6x, we could say that, well, now I'm going to have to do a u substitution. So I'm going to go over to the side. I'm going to say, well, u is equal to 3 minus 6x. So then du dx is negative 6. du is negative 6 dx. So then negative 1/6 du. Yeah, that should is dx. Oh, man. I need to remember that I can't go off my mouse pad thing. Okay. Can't go off the playmat. So if I go in and do my u substitution now, I've got my 4 integral 1 over u, and instead of writing dx, I'll write my negative 1/6 du. And now I can pull that negative 1/6 out front. So now it's a nice straightforward, well, negative 4 over 6 is negative 2/3, right? So I can say this is negative 2/3 ln of absolute value of u plus c. So to finish it up, we'll just drop u back in. So I'm gonna have to film a part 2 of this because somebody needs more attention than she's getting right now. So we'll make it work though. So hopefully I'll just come back in a little bit.